Greetings, Snapcoder. Hope things are fine with you. Just a quick one here on converting an algorithm to Snapcode. We're going to do it for the isPerfectSquare algorithm that we did just recently. And our algorithm was that we determined that if we compute the square root of the number n, and then we compute the floor of that square root, then when we compare the two, we know if we have a perfect square or not. So let's give that a shot. Let's move that right over here. Let's make the Snap browser a little smaller, and let's go ahead and make a function, our own function. So we can go to any of these palettes. I'm going to go to operators here and make a block. And we could call it anything we wanted, just a name, isPerfectSquare. And we'll call it a reporter because we want to report a value, return a value, and that value will be true or false, right? Yes or no, is it a perfect square or not? All right, make that bigger, of course, and we're going to have a parameter. We're going to have parameter n, the number, actually, or we could call it number, whatever. Just for fun, let's call it something different. Let's call it num to show that that's just a variable name. We'll get that out of the way. We'll use that a little bit later. We need to do these things here then, right? First, we'll compute the square root of the number. All right, let's make this a little bit more visible here so we can see our algorithm. All right, I'm just going to make this then so we can see that. And then what is that? All right, I think we can see that pretty good, and that pretty good. All right, there we are. So we'll go to our variables here, and we'll use the set. And we're going to have three sets here, right? We're going to set it 3 times. First time, we're going to set the square root. And I'm going to actually, what we want to do here actually is make some variables, some script variables that'll just be local to this script, or this, I should say, or this function, or my block is what Snap calls it. We'll call it a function. This function name is perfect square. So what are the 3 variables? Square root floor, and is perfect square. So let's say first variable here is going to be, we have 3. Change the name of that guy to square root. And this one's going to be square root floor. And finally, we have is perfect square. 3 variables. All right, now we'll set those variables. Square root floor, square root is perfect square, just like we're doing here in our algorithm. Square root is going to actually be the square root, right? So we want to bring that function over here. And the square root of what? The square root of n, the square root of the number, or the number. In our case, there we go. We call it num. Doesn't matter what we call it. Num, n, number, z, my number, my friend, my buddy. It's a variable name, whatever makes sense to you. Square root floor, it's going to be the floor of the square root. So again, we're going to use a system function here, or a snap function, and floor. Look for floor here. There it is. And this time it's going to be of the square root, actually. So right here, our algorithm says the floor of the square root. Now we're just going to compare to see if they're equal, to tell us if we have our perfect square. That's what our algorithm is saying we do, right? So we'll use the equality operator there. And it's going to be square root versus square root floor, right? Square root versus square root floor. And there we go. Last thing we want to do is just report it or return it. The word return is used in most languages. Snap wants to be unique, I guess, and uses the word report. So we're returning the variable there, which is going to be a true or false. We think, we hope. We'll say OK. All right, so now we don't really know if it's going to work until we test it, right? Never trust it until we test it. We want a variable, so we can show it over here in Snap. And we'll just call it, it's redundant, but we'll call it isPerfectSquare. You could call it again something else if you wanted to, if it made more sense to you, isPerfectSquare. All right, so we are going to set it here. I'm going to duplicate that, and isPerfectSquare. We're going to set it initially just to a blank. This is the initialization on the stage here, right here. Initialization. We're initializing everything to blank except the n to 0. And finally, on the Go button here, we're doing our calculation. Oops, what am I doing here? Edit. go? What happened to is prime? Okay, rounded square root is not there. Okay, that's okay. We're not computing. We're missing one for some reason. I'm going to add that in. I can add 2 in. Or 1 is the rounded square root. That is just from another calculation, and then we're going to add in here the one we just did is perfect square. So let's go to our calculations here. We have 1, the rounded square root, and 1, the is perfect square, which we just did. Both of those will take n as the parameter. Go back to variables, n. That just means it's going to set that variable to that calculated value, We don't know until we see it, right? So let's see what happens. So I'm going to hit the green flag here to start things off. I'm going to say edit, and we'll say 11. That should not be a perfect square, right? False, that is correct. It is not a perfect square. It is a prime, 11 is a prime. Okay, so let's edit that and make that our 16, which we know is a perfect square. Let's do go. Ooh, there we go. This perfect square is true. So it seems to be working. We could try a bigger number. 12 times 12 is 144, right? I believe. Another perfect square, a big one. 144. And go. And it is again true. We'll just do one more here, 145, which we know would not be perfect square. And we'll say go. And it's false. So it seems to be working okay. All right, well that is, again, that is algorithm to code. So not so fun, right? Enjoy, and we'll see you soon.